So today we're going to talk about the appendicular skeleton. That is the arms and the legs and the structures that hold the arms and the legs onto the body. So we're going to start just kind of with an overview of what we're looking at. We've got the clavicle, the scapula, and then the humerus, radius ulna, carpals, metacarpals, and phalanges. That's the upper limb. Then the two os coxae bones are going to hold the lower limbs to the body, and the lower limbs are the femur, the tibia, fibula, little patella right there, and then the tarsals, metatarsals, and phalanges down there at the bottom. So the girdles are the structures that hold the limbs to the trunk of the body. The pectoral girdle is the scapula and the clavicle, and that's going to attach the humerus to the trunk of the body. The pelvic girdle is just made up of these two bones, which we sometimes call the hip bones. They're called the os coxae, or the coxal bones. And notice that this does not include the sacrum and the coccyx. Okay, if we talk about the whole pelvis, then we include the sacrum, the coccyx, and this little pubic symphysis right here. But when we're talking about the pelvic girdle, we're just talking about the bones that are needed to hold the femur to the body. And so that's just these coxal bones, left and right. All right, so let's start with the clavicle. So here's the clavicle. You can see it's this little short curved bone, and on your own body, you can see your own clavicle right there. And you can actually feel that curve in the clavicle bone. The sternal end of the clavicle articulates with the sternum, hence sternal end, and it's pretty blunt, it's pretty tall. And then as you get across to the acromial end, that's this end, it flattens out. And I've got another view later, you can see that three-dimensional curving, thinning. So this is the medial end, this is the lateral end, and this is the top side, and you can see that top side is nice and smooth, doesn't have any tubercles on it or anything. The bottom side has a conoid tubercle here at the acromial end, and it has a costal tuberosity at the sternal end, and that's where rib number 1 is going to articulate with the clavicle right there. All right, now here's your scapula. Oops, excuse me. Here's your scapula. And the scapula, this is what you call your shoulder blade. Here's that acromion where the acromial end of the scapula articulates. And that's right here. It's got a little facet on it where that acromial end of the clavicle articulates. And then coming forward, there's another process called the coracoid process. We've had a bunch of other coronoid things. This is coracoid, so make sure you keep those distinct. Let's see, other markings. This whole part, this whole front of the scapula is called the subscapular fossa. And on your body, the scapula actually kind of tilts forward like that. So this subscapular fossa is actually on the bottom. It's actually under the scapula, the way that your shoulder blades actually sit on your body. And it is kind of indented. You can see that on a real scapula. This indentation right here is the glenoid cavity. That is where the humerus articulates with the scapula. And then there's a little scapular notch right there. The edges of the scapula are called borders. So we've got a lateral, a medial, and a superior border. And then these little corners are called angles, and we've got a superior angle and an inferior angle down there. Now, this is the scapula from the back. So you can see the acromion is actually the end of this long process here called the spine. You can call it the scapular spine or the spine of the scapula. Either of those is fine. And then we have fossae above and below that. Supraspinous fossa because it's above the spine. Infraspinous fossa because it's below the spine. And then here's that superior angle, superior border. There's that little scapular notch right there. And then you can see the coracoid process is going to the front. So we can't really see it as well from the posterior side of the scapula. And from the lateral view, now we can see this orientation between the coracoid process here, the spine, and the acromion here. And then the other thing we can see here is the tubercles above and below the glenoid cavity, named the supraglenoid and infraglenoid tubercles, because above and below the glenoid cavity, right? So that's that. This is how the scapula and the clavicle articulate together. And here you can see that the clavicle on this end is kind of thin, not very tall. And on this end, it's much taller, very blunt on that sternal end. And you can see that the way these two articulate together is kind of an unusual articulation. We think of joints as being kind of like that, where one wraps sort of around the other, and that's what we've seen a lot of so far. Here we have two just kind of go together like that. It's kind of an unusual way. There are a bunch of really strong ligaments that hold that together. So that's actually a very, very strong joint, which is why you unlikely to hear of someone dislocating their clavicle, but you may have heard of people breaking their clavicles because of the strength of those ligaments. This is what all of that looks like on an X-ray. So the coracoid process that is coming to the front, you can see that articulation there between the clavicle and the acromion, and then the head of the humerus sitting in this glenoid cavity. And now that you can see the head of the humerus, you can see how big this articulating area is. Big, smooth head of the humerus. And that enables your humerus to move in all kinds of different directions. But because this glenoid cavity is so small and not particularly deep, sort of like that, that's why it's relatively easy to dislocate your shoulder, because there just isn't that much bone holding it in place. There are ligaments that hold that whole joint together, but because it isn't a deep pocket that that head sits in, you can pop it out. It will damage those muscles and ligaments around it, but it does make it a fairly weak joint. And here it is, another X-ray showing all of those articulations there. Okay, now I have this on here so that students remember when you're trying to figure out whether a scapula is right or left, which you don't have to do this semester, to remember that the glenoid cavity goes laterally because you are not a dragon. Because if you did, you would have a space for a bone to articulate on the back of your body. So sometimes students come up to me and they've got a scapula and they put the spine on the back and then they hold it to their body and say, does this go on this side? But they've got the glenoid cavity here toward the medial side. No, your arms go on the outside. They go on the lateral side because we're not a dragon. If you were a dragon, you would actually have two articulation points. You would have one for your arms and one for your wings, unless you're a dragon in Game of Thrones, in which case you're actually more like a bird. You're a quadruped. See, look at that. Yeah, glenoid cavity on the lateral side. Skeletally correct dragons? No? All right, so that was the pectoral girdle, the clavicle, and the scapula. So now let's talk about these bones of the upper arm. And we have this organization here: humerus, radius ulna, carpals, metacarpals, phalanges. And this organization that's one bone, two bones, a bunch of bones, and then phalanges is going to be the same in the arm and the leg. So hang on to that organization: one bone, two bone, bunch of bones, phalanges for the arm and the leg, okay? The upper limb and the lower limb. All right, and I want to talk a little bit about the evolution of limbs and why it is that not only you, but actually all land vertebrates have that same organization in their limbs. And it's because we all have a common ancestor. This is what a fish limb looks like. And you can see this stack of bones with little bones coming off, and then these things, they're called fin rays. That makes up the little fish fin. And then you can see as these steps of evolution happen and creatures start using more of their fins to walk, like, you know, in the muddy shallows. You can think of fish sort of walking along the bottom. These are still fish. They live entirely in the water, but they have beefier bones and a more complex bone structure because they're using those fins to kind of move themselves around on the bottom. And we start to see this organization of like 1 bones, 2 bones, and then maybe some phalanges until we get here to Tiktaalik. And when we get to Tiktaalik, we see 1 bone, 2 bones, bunch of bones, and then phalanges plus fin rays. And this is the link or the transitional fossil between fish and land vertebrates. And you can see over here we have 1 bone, 2 bones, and then little bones and phalanges more distinctly here. These are entirely land vertebrates. So we've gone from creatures that live in the land to creatures that live in the water to creatures that live on the land. Tiktaalik is kind of half fish, half amphibian. And this is what they think it looked like. So this is me with Neil Shubin, who discovered the fossil of Tiktaalik. That's the actual model of the fossil skull. And this is an artist's rendering of what Tiktaalik rosier, that transitional fossil, would have looked like. You can see it's got this flat head, more like an alligator, but it still has fish fins. Okay, so it's got several characteristics of fish, several characteristics of land vertebrates. It is in between. It's a transitional fossil. And this is Shubin's book, Your Inner Fish, about the evolution of the human body from our fish ancestors. And it's really, really fascinating. It's really well written for anatomy students because it talks about the way that human anatomy is related to our ancestry, and that having this common ancestor with fish explains why certain structures on the body are the way they are. Okay, Shubin's lab did another study where they looked at what genes make fingers and fish fins. They thought it would be separate genes, and it turns out that they're actually the same genes. So the glowing green here and the glowing green here means that the same genes are making these fin rays as the fingers. So these are really just modified fins. Cool. All right, now let's talk about the humerus. So the humerus, this is your upper arm bone here, okay? The head of the humerus is this big, round, smooth, articulating surface, and then the anatomical neck of the humerus is this narrower area right here. It's where the epiphyseal plate is. And then on the humerus, we have 2 bumps. The greater tubercle you can feel is this little bump on your shoulder right here. That's the greater tubercle. Remember, a tubercle is sort of a potato-shaped lump. And because we have a greater, we also have a lesser, and the lesser is on the front. It's about right here. And in between them is the cleverly named intertubercular sulcus. And that's that little indentation right here. My line's kind of in the wrong place. It's a groove, sulcus means groove, between these 2 tubercles. So that's what its name literally means, intertubercular, between the tubercles. So greater tubercle, lesser tubercle, and then intertubercular sulcus. And if you don't have a really strong deltoid, sometimes you can actually feel that sulcus right about there. Right? Now, if you go down the lateral side of the bone, you get to this bump right here called the deltoid tuberosity. And that's where your deltoid muscle inserts. This is hard to see on a lot of bones because our bones come from people who died, who were often elderly and often infirm before they died, and didn't work on developing their deltoids. And so this deltoid tuberosity often gets smaller, gets reabsorbed by those osteoclasts we talked about. Anyway, that's right about there. That's where your deltoid muscle inserts, that deltoid tuberosity. Now, this is the distal end of the humerus and the anterior side. So you can see we've got 2 fossae here. We've got these smooth surfaces here that look like bone-on-bone articulations and these bumps on the sides. So let's walk our way through these. So we've got these epicondyles here and here. Epi means above or on top of. So these are above the condyles. The capitulum and the trochlea are actually condyles, although they have special names. So on the exam, don't call them medial and lateral condyle, call them by their correct names. So this one is the capitulum, it's on the lateral side. The radius is going to articulate with the capitulum. And when your elbow is bent, the head of the radius fits into this radial fossa. So that'll make sense. On this side, we have the trochlea. The trochlea is, this whole thing is one condyle that has a groove in the middle. And that groove is going to accommodate the coronoid process of the ulna. So when you bend your elbow, that coronoid process of the ulna is going to fit into this coronoid fossa. Okay, trochlea means pulley. So this has this groove in the middle, just like the ring on a pulley. The wheel on the pulley has that indentation in it. If you're not familiar with pulleys, the little wheels on your window blinds, it's basically a pulley that has that little groove that the cord goes through. All right, now we're going to look at the back side, the posterior side of the humerus. Here we're back at the proximal end, so you can, here's the head and the anatomical neck, the greater tubercle. We can't see the lesser tubercle because remember it's on the front. Okay, so the lesser tubercle and the sulcus, the intertubercular sulcus, they're on the front. So we can only see the greater tubercle looking at the back side of the bone. We can see the surgical neck. It's called the surgical neck because you're most likely to have broken the bone there. Deltoid tuberosity, and then just behind the deltoid tuberosity is the radial groove, which accommodates the radial nerve. So the radial nerve is going to go down that to the hand, or to the radius, excuse me. And then down at the distal end, we see just one fossa, the olecranon fossa. And the olecranon process of the ulna is going to go into that fossa. And that's going to make the little point on your elbow right there. That's the olecranon. You can see the medial and the lateral epicondyles. You can see the trochlea, but notice that you can't see the capitulum. Okay, it's entirely on the front of the humerus. So from the back, you don't see that capitulum. So that's how you can distinguish the front and the back of the radius. Back has one fossa, okay, for that elbow thing. Back has one fossa, front has two fossae. Okay, so here's what the ulna looks like. And you can see it's got this really funky looking olecranon process here. This is the coronoid process, which is pointier than it looks. You remember coronoid means sort of vaguely pointed like a crown. It doesn't look that pointed here, but I've got another view where you can see it more clearly. And it's got a radial notch. Guess what inserts in the radial notch? Yes, it's the head of the radius. I know who would guess. So the head of the radius is going to fit in there. The radius is actually going to turn in that radial notch. And then the distal end of the ulna, look how skinny it is. It's a really tiny bone. A lot of students, they concentrate on this end and they think distal end is going to be beefy too, but it's not. It's really skinny. That's going to be important in just a minute. It also has a little marking over here called a styloid process. And I have another picture I'll show you that where you can see that a little better. That is going to make this little bump on your wrist right there. That's the styloid process of the ulna. This is the radius, and you can see the radius has this really distinct ridge running all the way around the head. This is the articular cartilage, that white spot, okay, showing how where it articulates. This round ridge around the head of the radius is going to rotate in that radial notch on the ulna. So the radial notch is like this. Head of the radius is going to fit in there and rotate like this, which enables you to do this, to rotate your arm back and forth. So that's your radius actually twisting back and forth. We also have a radial tuberosity where we're going to have some muscle attachment there. And then down at the distal end, an ulnar notch that accommodates the ulna. So the ulna has a radial notch and the radius has an ulnar notch. And then we also have here a styloid process, and that makes this bump on your wrist there, okay? This is how your elbow joint fits together. So this is the anterior side. Here's the head of the radius. You can see that nice smooth ridge around the edge. fitting onto the capitulum, and then this radial fossa here, the lateral epicondyle. And then here's the trochlea, and now you can see that pointy point of the coronoid process, pointy point being technical terminology. And that fits into that coronoid fossa there. And you can see that pretty big, distinct medial epicondyle. That's this bump of your elbow right there. On the back, see the olecranon of the ulna. That olecranon process fits into that olecranon fossa very nicely. And if you are double jointed, meaning that you can bend your arm past straight, it has to do with the formation of that joint. Either the shape of the olecranon or the fossa enables that to basically open past 180. That's what double jointed of your elbow means. Now, radius and ulna here at this joint, the radius is always on the lateral side. The ulna is on the medial side. So if you hold up your arm like this, you say, rad, dude, your radius is next to your thumb, okay? Your radius is always gonna be next to your thumb. And then if you hold your pinky out like this and make a little U with it, your pinky is next to your ulna. Get it? U, ulna, okay? So rad, your radius next to your thumb, ulna next to your pinky. Now if you turn it over, guess what? It still is. Remember how the radius rotates, okay? So the radius is still next to your thumb, ulna next to the pinky. What's happened to enable that is that the radius actually crosses over the ulna here. So if you put your fingers around your wrist like that and turn, you can feel those bones moving. That's your radius crossing over the ulna. All right, that's an X-ray. So we can see how all of that fits together. And this is a lateral X-ray. So again, you can see how this coronoid process there fits into that trochlea, and the olecranon process fits in there, the trochlear notch there in the middle of the trochlea, okay? The radius and the ulna articulate together like this. They've got an interosseous membrane between them that hold the radius and ulna together. So if you imagine like you did a handstand, you're putting a lot of pressure on these bones. This interosseous membrane holds them together so that they don't go like that, so they don't bow out. Because of that, both bones have an interosseous border or an interosseous ridge or an interosseous crest where those membranes attach. There's the radial tuberosity. There's also an ulnar tuberosity. And then there's that radial notch, and down here we have that ulnar notch. And here's a close-up of both of those. So the head of the radius fits in that radial notch, and the distal end of the ulna with its little styloid process, you can see that clearly there, fits in this ulnar notch on the radius. And then there's the styloid process of the radius. So both of those bones have styloid processes that make those bumps on your wrist. All right, now, if you hold out your hands, palms facing down, your hands are pronated. If you turn them over, your hands are supinated. You can remember this because when your hands are supinated, you can hold a bowl of soup. When you pour it out, pronated. Get it? Pour, pro. Get it? Get it? Okay. Supinated, pronated, supinated, pronated, supinated, pronated. We can do that with our feet too. Okay. Your feet are normally pronated. You can also twist them a little bit one way and the other to pronate them. If you are lying face down, you are lying prone. If you are lying face up, you are lying supine. This shows you that crossing over of the radius and the ulna. So here is the right forearm supinated, and you can see that radius and ulna lying parallel to each other. And then when your hand is pronated like this, the radius crosses over the ulna. So it actually rotates up here and then twists. The ulna doesn't twist. The ulna has that big olecranon and notch that goes around the trochlea. So it is only a hinge. It just hinges this way. So when you twist, you're twisting the radius across the ulna. There. Okay, and you can see they cross right there. Now, we are ready for the carpal bones. These are your wrist bones. So, carpal bones. I learned them in order. Let me use this hand. From the thumb to the pinky for the proximal row, and then back to the thumb to the pinky for the distal row. Okay? And so they are scaphoid here articulates with the distal end of the radius. Notice how big the distal end of the radius is. Students sometimes get confused. They're thinking ulna is big, so the distal end must be big, but the distal end of the ulna is really skinny. The distal end of the radius is bigger. So the scaphoid and the lunate, the next one, both articulate with the radius. The triquetral or triquetrum articulates with the ulna partly, and then the pisiform is this little sesamoid bone. The sesamoid bone is just a little roundish bone shaped like a sesame seed, and the sesamoid bone makes this little bump on the heel of your hand right there. That's your sesamoid bone. Okay, so that's your first row. I'll do it on this hand. Scaphoid, lunate, triquetrum, pisiform. Then we're going to go back to the other side. Trapezium, trapezoid, capitate is kind of in the middle here, and then hamate. Your hamate bone, I'll show you a picture of the real bone. It's really distinctive. It has a hook on it like this. So you can remember hook on the hamate. So we do have a mnemonic for remembering it, and it is shy lovers try positions that they can't handle. So shy for scaphoid, lovers for lunate, tri for triquetral or triquetrum. I love that one because tri, that's helpful. And then positions, pisiform. Then we go back over to the thumb side. Trapezium, trapezoid, that's that they. Capitate is can't, handle is hamate. Now the one other problem that I had was remembering whether it was the trapezium first or the trapezoid. So the way I remember it is when I can't remember something, I say oh. So trapezium, then trapezoid, oh. Okay, so first and then oid. All right, so that is one of the mnemonics. There's another mnemonic that goes this way. Oh, let me go that way, okay? So it starts from the thumb, goes across to the pinky, and then circles back around to the thumb side. And this one is so long to pinky, here comes the thumb. And a lot of people like this one because it says pinky and thumb in it, okay? So long, scaphoid, lunate, to pinky is the triquetral and the pisiform, and then here comes hamate, capitate, trapezoid, trapezium, okay? So just remember trapezium is right at the bottom of your thumb, trapezium, thumb, okay? Whichever one works for you, memorize that one and use that one. This is what all of that looks like on an x-ray. You see this big distal end of the radius articulating with the scaphoid and the lunate. Here's the triquetrum articulating with the ulna. This x-ray is taken from the dorsal side, so we can't see the pisiform because the pisiform is here on the ventral side. Okay, so that is one thing to remember. If you ever see an image or a picture that doesn't have the pisiform, it's because it's from the back side of the hand. Okay? And then trapezium, trapezoid, capitate, hamate. These are some images from a drawing magazine, art magazine about drawing, just talking about, just showing the markings and how these markings affect the surface anatomy. So if this is helpful for you, go ahead and take a look at those and that one as well. We'll come back to this one when we do the muscles. So those were the carpals. We've done the carpal bones now. Those all fit together. And now let's do the metacarpals. The digits are numbered 1, 2, 3, 4, 5, starting with the thumb. And the thumb is called the pollex, P-O-L-L-E-X. So this is your pollex, okay, and that is also digit number 1. This whole thing, the metacarpal and the phalanges, is the digit. Sometimes we just say this is the digit, but all of this is the digit. So, but just remember that these metacarpals, they make the palm of the hand, and then the phalanges make the fingers. These are the bones that make the fingers. All right, so when we number these, we can use, we can either say like first metacarpal or third metacarpal, or we could say metacarpal number 3. Either of those is fine. Then when we look at the phalanges, we see that the thumb has 2 phalanges. Now, phalanx is the singular of phalanges. Okay, so you have 1 phalanx here, 1 phalanx here. So a proximal phalanx and a distal phalanx together, 2 phalanges make up the pollex. And then fingers 2 through 5 each have 3 phalanges, proximal, middle, and distal. And notice this is middle, this is not medial. Medial means toward the medial side. Middle means in between, okay? And we're gonna see this between proximal and distal. We're also gonna see it between medial and lateral. So make sure that you either use the term middle or intermediate is the other one you can use, but do not confuse medial, which means toward the middle, with middle, which means between 2. So digits 2 through 5 have proximal, middle, and distal phalanges. So if you display the phalanges of digit number 3, that would be rude. If, on the other hand, you display your proximal, middle, and distal phalanges of digit number 5, then you're just drinking tea. Get it? So I could ask you, what is this bone here? You would say middle phalanx number 4, or intermediate phalanx of the 4th digit, or something like that, okay? This shows, this is an X-ray showing the bones, and this shows how they actually orient on your hand. And I like this one because you can actually see where the carpal bones are, because I had a hard time kind of getting to where I could visualize where these bones are. The other thing I like is you can really clearly see here the hook on the hamate bone right there. You can also see that there is a tuberosity here on that trapezium. And there is a ligament that goes across that space and creates a little pathway. The tendons for the muscles that move your fingers, they're going to actually, the muscles are mostly in your forearm, and the tendons go through that little space into your hand, attached to the bones in your hand so that you can move your hand. That little space is across the carpal bone, and it's almost like a tunnel. That little space is called your carpal tunnel. So from the hamate hook to the trapezium, the ligament creates the carpal tunnel. If you have carpal tunnel syndrome, it's because you have irritated one or more of the tendons going through that carpal tunnel. Cool, right? I think that's where we ended. So I'm going to end this lecture there. I'm going to post this, and then the other 2 are separate lectures. So there you go. Enjoy your appendicular skeleton.